Alrighty. Good morning, everybody. Welcome to here in pre-calculus. Okay, not quite everybody, but we'll send it off anyway. All right, this morning's quote is a reminder to always, no matter what, keep going, right? No matter what it takes. And we are going to keep going today, despite my having kind of screwed things up a bit. Just a little bit. It's not going to throw us off entirely, but we'll just get to it. Today, we are going to talk about holes. And you may realize that, wait a minute, we kind of did that Monday anyways. I completely forgot that I had carved aside today to focus on finding all the holes in our functions. Remember, we've been dealing with these same functions throughout this unit and just iterating on, okay, finding the next piece of information, find the next piece of information, just adding and building on top of that. Well, in our quest for the asymptotes, you may recall, we had this check with the excluded values. Hey, wait a minute. Get all your excluded values. Where does the denominator equal 0? If it was also one of these zeros of the function, well, then we throw that out. That's a hole, not an asymptote. Which means I already covered how to check for holes. So I don't have much left to add for today. But I thought about it a little more, and I said, you know what? There's a better flow for this. So I'm going to share with you my preferred workflow in dealing with these. Instead of going for the asymptotes right away, I still would consider the highest powers first. So let this still be your step number one, because it most often going to be the form you encounter these in. They'll already be two polynomials in standard form, one in the numerator, one in the denominator. And so you can find that highest power. And this is barely even a calculation. You're comparing two numbers to find out who wins. If necessary, then do a division of their coefficients to get that horizontal asymptotes. I would still start there. But after that, because of this nature of holes, if they're present, they throw everything else off. You want to get through those first. So here's my revised order of operations, as it were, when dealing with a rational equation. This is only a recommendation. I would start by factoring. Factor both sides, factor the numerator and the denominator, okay? And that's going to save you a lot of headache, because right there from the factoring, you don't even have to actually solve for anything yet. You can reduce any duplicate factors, right? Let's use the tried and true example. Let's say you factor this guy, you end up with x minus 1, x plus 1, and x minus 1 on the bottom, right? Factor first to get to this stage. Then next you can reduce, and the reductions become your holes. Okay? Reductions become the holes. Anything that got reduced out is a hole, by definition, right? A hole is really, the proper term is removable discontinuity, and what you've done is you've just removed it. Then take your numerator, denominator, ZPP on those guys, the remaining numerator, denominator. Solve those, zero product property, right? Take each factor, set equal to 0, solve for x. And then you will create, again, from the numerator, list your zeros. That'll be all these solutions from the numerator. And list your vertical asymptotes. That'll be all these solutions from the denominator. Okay? So hopefully that process will speed things up a little. Again, we've kind of already done a lot of this on these particular functions, but don't worry. You'll have a fresh set where you can start from scratch eventually. That's how I would tackle this. Okay, any questions on that? No. Okay, then what I want you to do with the rest of the day is quite simple. You need to go back and double check all of your functions. And please, yes, actually take 5 minutes, double check, okay? Even if you feel fairly confident. What else are you going to do today? Okay, double check all of your supposed asymptotes, your excluded values, and reevaluate whether any of them appear in the list of zeros. So again, here is question 2. We found the excluded values included 5/2. The zeros values included -2 and 5/2. So since 5/2 is in both of them, we actually end up with a whole at 5/2, vertical asymptote nowhere, and a 0 of the function at -2. Okay? So go through, double check all of those, and you should end up with that final list of features, including your y-intercept. That didn't change at all. And your wholes, vertical asymptotes, and zeros. And once we have that final list, now we can go back, and we'll be doing this tomorrow. We will actually start graphing these ones in particular. Okay? So that's all I've got for you today. It's a pretty short and easy sort of day. You're welcome. It doesn't come all the time, but you know, sometimes you deserve a break. So there you go. Take advantage of it, and don't just like be a slouch on the couch afterwards. Like, make some use of this extra time if you got it. All right? So let me know if you have any other questions, but I'll leave you to the rest.